All right, well, welcome everybody. I'm Dave Small, president of the Outlaw Bird Itcher Club, and here we are for our May evening meeting. This is the height of global migration that's happening now. It's kind of a great time to be out and listening to birds and feeling what we have. And most of us have discovered this new app for our phones called Merlin. And tonight we're going to learn a little bit about what makes it tick. So we're really pleased to have Grant Van Horn with us today. That's going to kind of unravel some of the mysteries of how these birds are telling us the wrong answer some of the time. Anyway, with that said, we'll please welcome Professor Grant Van Horn.
Yeah, thank you guys. So I'm a scientist at the Cornell Lab of Ornithology and a new assistant professor at UMass Amherst in the computer science department. I'm not a biologist or an ecologist. I would call myself a birder now. All my training is in computer science and artificial intelligence and the subfield of machine learning. And so I've been lucky enough to work with groups like the Lab of Ornithology for over a decade now. And a lot of my research is focused on applying machine learning techniques, artificial intelligence techniques to helping people solve problems like recognizing birds in pictures as well as in audio. And so today we'll talk about the Sound ID project that we built for Merlin. And please
Hold that picture off there. A little bit, just
Picture.
yeah, so here, just move it up out of the way.
There we go.
So, anyway, hopefully that'll work.
And please interrupt for questions at any time. If I say something that doesn't make sense or you guys want more information, just stop me and we can dive into the details. If you've never been to Ithaca in upstate New York, this is one of the trails that you'd find there. This is right out the back door of the Lab of Ornithology. And I'll play a little bit of audio here in just a second. But this is a motivation slide of kind of like what we were envisioning or what we wanted to solve when we set out to build Sound ID. And that was, you're walking down this trail and you're just hearing bird song and bird calls. And man, wouldn't it be nice if something could tell you what they were? Now, I was lucky enough at this time to be walking with, probably some of the best birders, at least in upstate New York, and they could point out everything to me. But as a novice, I just was not able to do it. But let's take a listen to what the challenge is. And so, it was walking down those trails and just hearing these different birds vocalizing off to the left, off to the right, behind us, in front of us. And again, when you're with someone who just knows all this stuff and they can point it out to you, it's quite magical. But when you're by yourself or you're just beginning to bird, that is like, you can enjoy it, but it's difficult to actually appreciate, who are the different species. So we wanted to make an app that you just open up and it would just start highlighting when it recognized the various species. Now, there's still, challenges of kind of learning which call belongs to each species, but this is a heck of a lot easier than not starting from this list at all, right? And so that from that little subset, you can then go try and visually find these birds or confirm their vocalizations. But that was what, we had this idea of what we wanted to build, and that was really what we were aiming for. And so today what I'll talk about is how we built this thing. And it's not done, and it's not perfect by any measure. It's a continuously improving system, and hopefully if any of you guys are e-birders, then you are directly contributing to making this thing better. And so I'll go through some of the ways that you all can actually contribute to Sound ID and make the next model release that much better. So some of the things that we'll touch on is how do we build Sound ID? Why doesn't Sound ID work for just all bird species immediately? How well does it perform? And how can you improve it? And kind of the thing I want to start with is like a zoomed out picture of Merlin Sound ID. And the first thing to note is that we're not dealing with like a linear line here. Everything's going to be a circle. So we're gonna go through a few steps, and we actually take these steps constantly. So first step is to collect audio. We'll see where this audio comes from. We next annotate that audio, which basically creates training material or teaching material for the AI system. We then teach the AI how to solve the task, and then we test it. And the test part is by far, I mean, besides the collecting of the audio in the first place, that number 4 step is the most important, because that gives us insights into which species are performing well, which ones need more attention, how can we possibly fix those species that need more attention. And that is what we'll sit here and do. And we do this kind of on a weekly basis of collecting more audio, annotating that audio, teaching Merlin how to recognize the songs that we just annotated, and then quizzing it and seeing if it's improved, and just keep cycling through this. So this first step is collecting audio, and this is directly from citizen scientists. All of our audio for the Merlin Sound ID project comes exclusively from the Macaulay Library, which is a large repository of media that is mainly contributed to by the eBird community. So at Cornell, there are kind of 2 flagship citizen science applications. One is Merlin, that we're talking about today. The other is eBird. And eBird is really the data collection app, right? So you go outside and you can start what we call a checklist. And for a certain amount of time, you can record all the species you're observing, and you give us counts of those various species. And you can also associate media with the checklists. And the media can be photos, audio, and we're working on getting video upload as well. But it's folks out in the field with potentially specialized equipment that you're seeing here. So Andrew, who's one of the staff scientists at the Macaulay Library, is recording, very, very close to his subjects in this bottom left picture with a parabola and a special microphone in it and a special high performance recording setup. These guys are again up in upstate New York near Ithaca. They have what we call shotgun mics. The 2 individuals on the right, the one on the left has a shotgun mic as well as a parabola. The parabola helps focus the sound and gives a better recording of the subject. We'll also take audio from just cell phones, right? So if you just have your phone out and you're recording audio off your cell phone, we'll also take audio that way. But a few more examples. So Cornell will sometimes sponsor students, undergrad and graduate students, to go to specific places to collect more media for species that we just don't have possibly any media of. So we might not have any audio recordings of their vocalizations, or we might not have any photographs of that particular bird. So we'll sponsor students to go, in this case, down to the Ecuadorian Amazon and specifically collect audio for what we call target species that we're trying to teach Merlin about. And again, same kind of thing. So you can see Glenn, who's another staff scientist on the project, who helped lead this expedition, has a shotgun mic with a parabola setup. And so you point it at the bird that's vocalizing, and you get a really clear, nice recording that we then, I'll show you guys, upload to the Macaulay Library for archiving. But anyway, the other thing is Glenn also has his phone running at the same time. So he's actually collecting audio on a really nice setup, as well as just his phone right next to him. Okay, so, citizen scientists, folks like yourself, go out into the field, you do your checklist. So this is an example of a checklist that got uploaded to the eBird project, and you can associate media that you collected with that checklist. So here we're seeing a few audio recordings for this sand grouse, and a few more audio recordings for this Iberian gray shrike, and 3 audio recordings for this lark. So you can create different audio files and upload them to specific species. And those now become the target are the kind of the central species for each one of those audio files. And this is the data that I want to play with. We do that, I do that mainly through the Macaulay library. So that previous interface was eBird. That was, again, the other flagship citizen science app from Cornell. All of the audio that comes in on those checklists gets archived in the Macaulay library. And what you're seeing here is a visual representation of the audio. This is called a spectrogram. We'll talk a lot more about those in a few slides. But you have the audio down here. You have, the associated metadata, such as the location and the date that the recording was done, as well as things like who made the recording. And in this case, what was the target species? You know, which species was trying to be recorded in this audio file, in this case, a lark species. Okay, so the Macaulay Library, Cornell has been collecting audio for a long time. The very first bird recordings were actually done in Ithaca in 1929, and we've been collecting audio ever since. So, oh no, we'll not do the. Bummer. I spoiled the little display here. This was supposed to be actually, let me see if I leave projection mode. Okay, so what you're seeing here is a black square that is going to get filled in over time. If this was not there, you'd see the year at the top of the slide. But it's getting filled in with as we receive audio. So the date started in about 1950, and then it ends in last year. And so it's just a black square with yellow dots. And so the continents start kind of popping out because that's where people go to do audio recordings. And so you can see that the Macaulay Library has a lot of audio from North America, United States particularly. Some in places like Western Europe and India, a bit on the east coast of Australia, and a bit in South America. But there's a black hole for Africa, as well as most of Asia and Russia and Southeast Asia, right? So we have big data gaps that we're trying to fill. And again, this kind of goes back to Cornell sponsoring specific expeditions to try and go to some of these places and collect more data, as well as engage with local organizations to try and spur more citizen science operations in these various countries. But this is the data I get to play with. So we've been collecting data almost for 100 years. But it's been obviously it was a slow start. So this plot doesn't even kind of go back to 1929. I just started at 2010. A really slow start up until about 2017, when you start seeing our monthly audio uploads start really jumping. Those periodic spikes are spring in North America. All right, so everyone gets excited about the spring birds, and we go out and we do audio recordings. And so this cumulative, we actually are almost about to hit 2 million audio recordings already. So this plot needs to be updated. But yeah, this inflection point for 2017 was when the eBird project started allowing people to upload audio as part of their checklists. And so I could make a duplicate plot of this actually for video right now. For video, we're almost flatlined at close to 0. And we're trying to get eBird to open up video uploads. And we're hoping to see a very similar thing where we start getting lots and lots more video media for all the species in the world. Yeah, so we had a slow start, but now we're getting lots of audio data to play with. And this is what I need as a computer scientist to train an AI to do these tasks. I need lots of data to play with in order to build what we'll see as the training and evaluation data sets. It would be really nice if we got uniform media in terms of the number of samples, the number of audio recordings for all the species in the world, but that's absolutely not the case. We get what we call a very skewed distribution. So this is a plot with log scaling, and we're seeing that we have some species with over 10,000 audio recordings. In this case, the red crossbill as the species with the most audio recordings in the Macaulay Library. We had 1,762 species have at least 100 audio files. And basically every species has at least one file. That was like one of the big accomplishments of the Macaulay Library a few years ago, was it got, the bird taxonomies change. So it's always kind of in flux, but we basically got at least one audio file for nearly all the bird species in the world. But most of those species have, again, maybe one or two or three audio files, not nearly the amount of training data or materials that I need to teach an AI system on how to do this. And so to answer one of those questions that I posed at the beginning, why doesn't Sound ID just work for all the bird species? This is why. We just don't have that much audio recordings for most of the birds in the world. We're getting there. We're chipping away at it, but this is going to be, 10 years, 20 years kind of in the making to collect all of this data to get a high-performing system that works for most of the birds in the world. So the species that I focus on, the species that I want to work with, are these birds that have at least 100 audio files. Because from that amount of data, I can sample a testing set to quiz Merlin to see how well it's doing, and I can sample a set of assets to teach it. And I need to be able to do both in order to build the system. Okay, so we don't get to play with all the birds. We get to play with just a subset that have enough data. How do we actually choose the audio files to train and test Merlin? I'll kind of walk through that process for the yellow-rumped warbler. So at a high level, what we do is we look at a map of all of our audio recordings that contain this species, and we group those audio files together on space and time. So it's a little bit difficult to visualize the time axis here, but what you're seeing here is like a Pacific Coast winter cluster. So these are all audio files that contain the yellow-rumped warbler that are kind of taken on the Western United States in the month of like January. So we kind of expect very similar vocalizations to be occurring in those in that collection of audio files. And similarly, this cluster is like a New England, Northeast United States May collection of audio files, right? And so we kind of expect the bird to sound different in those audio files as opposed to the West Coast. Maybe they'll sound similar, but we expect some kind of diversity in those audio files. And the reason for clustering these together is so that we can make sure we sample from each of the clusters, right? So what happens is the yellow dots are audio files that we've sampled from these various clusters, and it tries to, the goal is to have those yellow dots and the green dots, which become our test, or the assets we use to quiz Merlin. We really want them to span the United States, or at least the range of the bird, in this case, yellow-rumped warbler, both across space, so literally across the United States, and time. So audio files from all the different weeks or months of the year, so that we get its chip notes, its songs, its flight calls, all the repertoire diversity that we'd expect users of Merlin to encounter out in the field. So we went from all of these blue dots. We start with all those blue dots, and we kind of boil it down to these yellow and green dots. And this is our starting point for yellow-rumped warbler to train and evaluate the system. So yeah, and sorry, I wish I could get rid of this Zoom thing.
Let's see if I can go up here and see if it's got a thing to say hide. Or is it somewhere hide something?
Hide the floating meeting rooms. Yeah, there you go. Nice. Perfect. Okay, that's better. Nice. That's much better.
All right.
Okay,
About that.
thank you. Okay, so we went from all those blue dots to just our yellow and our green dots. And the way to think about those yellow dots is those are the homework for Merlin. It gets to use those to go and study how to recognize yellow-rumped warbler, at least its vocalizations. And then the green dots are the exam, the quiz, right? So we have the answers. Merlin doesn't get to see the answers. It just has to make predictions on when it thinks it's hearing yellow-rumped warblers in those recordings. And if it doesn't do well enough,
on its quiz, then we'll go back and try to give it more homework, improve the quality of the homework until it does a better job on the exam. We'll see that in more details here in a few slides. Okay, so that was all in the first step. That was our collect audio, right? So that was get eBirders and citizen scientists to go out in the field, make recordings, get that stuff uploaded, look at the distribution of recordings for a given species and try and sample some stuff to use for training and for evaluation. We'd like to get straight to number 3, but first we need to do more work with those recordings. We do an annotation step. And so we'll listen for the next few slides. It's going to be the same audio file. We'll explore why we bother to annotate, why we have to do this. This is a really painstaking step. This is a kind of a bottleneck in this process. But doing it leads to way better performance. And so let's kind of motivate this. So why annotate? Let's see, will this autoplay? Well, I'm going to play one of Yellow Rump Warbler's training materials. And I want you to think like, if someone gave you this audio file and told you this is what Yellow Rump Warbler sounds like, would it be useful or not? So it's just 20 seconds. Okay, so that is what Merlin gets to learn, right? And there's a lot of stuff going on in this audio file. And all we said was like, hey, Merlin, Yellow Rump Warbler's in this thing. Like, go and learn. And by the way, this, again, is that spectrogram. So you got to listen to the audio as well as see the audio scroll past. This visual representation is also what Merlin uses to recognize these vocalizations. So it's looking for these little squiggle patterns to decide whether something is currently vocalizing or not. But that's its current training material, and it's arguably very difficult to do anything with that, right? Like if someone gave you that to learn about Yellow Rump Warbler, like you might confuse it with many other species. So someone raised their hand. Can that person talk?
We'll probably have to let them.
Okay.
But we can. Why don't we hold the questions till after?
Okay. Yeah.
So that we can go back.
That sounds good. So, let's see. I don't want to play this again. Sorry. Okay. That's really hard. I'm going to play the exact same audio, but now we're going to go through an annotation phase. And hopefully, again, like put yourself in the shoes of Merlin and see if this is a lot easier to learn from. Okay. So now this audio file has detailed annotations of what's vocalizing when and where in this audio file, right? So in this current view, we can see that a northern cardinal is about to vocalize. The red line is the current audio that's being played. So northern cardinal is about to vocalize. That Yellow Rump Warbler chip note is about to be encountered. There was a previous Yellow Rump Warbler chip note, as well as a Vesper sparrow, and a red-winged blackbird is also vocalizing, right? So now we've got a lot more information to figure out what is the Yellow Rump Warbler, what is the Vesper sparrow, what is the northern cardinal. So the raw audio is, we have to have that, but that alone is not good enough to teach Merlin how to do these classifications. And to do that, we have to do this boxing. So I have to. Don't want to play it. Let's go to the next one. There we go. Okay. So how do we do all this boxing? We built a tool that we call Merlin Vision. And in this, it's a web-based tool. In this tool, we've created projects that are mainly structured around different countries and areas of the world. US and Canada is our kind of our flagship. That was our first project that we launched, and we've since expanded into other regions. But we select species that are relevant for those projects, and we have domain experts, birders that are just amazing at listening to audio and telling you what's vocalizing, come in and help do this boxing task. So this is a little animation of someone doing this on an elegant Trojan recording. So there's no sound, but they play with a spectrogram, and they're listening to the audio. And they play with a spectrogram and they put the boxes down where that species is vocalizing, right? So all of those red boxes are these elegant Trojan vocalizations, and there's a flycatcher vocalizing here that he's found, and he puts another box there. And so this is this process of, and you can kind of, it's fun to like watch him. So he'll listen to the audio, he'll play it, and then he'll go back and he'll box these things and label their respective species. But this is what it takes to build up the training data set for Merlin. And this is kind of another reason, like, why doesn't Merlin just do all the birds? Well, for every piece of training and testing sample for the data set, we have to do this process. It can get very complicated and very busy. Lots of overlapping species, just diverse repertoires. And so you really, this is not a public tool. This isn't something where anybody can come and just start drawing boxes. We've limited it, it's kind of like friends of friends that we really trust to know what they're doing to come in here and annotate all these species. We'd like to kind of loosen those constraints so that more people can help contribute to this process. But yeah, for now, it's still just, actually, we'll see some stats in just a second. It's something like, I think we've had maybe close to 300 people help contribute boxes, but maybe like 20 people have done most of the boxing. And those are probably the true heroes of Merlin Sound ID, is these folks that are doing this task. Yeah, actually perfect. So myself and two others started Sound ID in 2020. And it was actually the person who did a lot of these annotations, Taylor Brooks, who did her undergrad actually here at UMass. She and I kind of kicked off this project. And so now we kicked it off in about March of 2020. The first two species that we studied were alder and willow flycatcher, because they're visually so difficult, but acoustically they're quite easy. So we got excited when we saw good results there, and we expanded out. We've had 259 annotators contribute those boxes that you saw being drawn. There's been almost 2.5 million boxes drawn on over 225,000 audio files. We have a box for over 4,000 species. The public version of Merlin that you can get from the Apple App Store or the Google Play Store, it only supports 1,300 or 1,400 species. And part of that is some of these birds just don't, even though they have data, they don't have either enough data or they're not getting good enough performance for us to want to release it to the public. So yeah, but we're getting there. It's kind of fun. Northern Cardinal has the most boxes right now. It's about to be passed by red-winged blackbird, which I'm so surprised. House sparrow is also clawing its way back, right? So this bird occurs around the world, and we should be seeing it in lots of these things. But yeah, for a long time, Northern Cardinal was by far and away the most common box bird in our data set. But red-winged blackbird is now is just about to pass it. Again, this I can't emphasize enough that this project is happening daily, right? So we're building this data set every day. We're testing Merlin every day. We're retraining it weekly. Yesterday, we got our first annotation for this red-billed emerald. Today, we got our first annotation for this sooty ant tanager, right? So these birds, there's a long time before they're part of the model and released to the public, but it's pretty cool to get kind of our first boxed vocalizations for them. Okay, so we've gone through steps 1 and 2. So we got citizen scientists out recording audio, and we have dedicated experts that are drawing boxes on those audio. And now it's time to teach Merlin. And so here we'll go into a little bit more details of the spectrogram. So, birds produce noise that propagates to your phone as sound waves. Your phone has a microphone, which is a transducer. It converts energy from one form to another, in this case, mechanical energy into electrical energy. So on your phone, when an app requests access to the microphone, what the operating system on the phone does is deliver this waveform to the app. So the app just gets this little squiggly blue line. That's what we get when we ask our iPhone, hey, can you turn on the microphone, and we want to listen for birds. So Apple's like, surely, here, I'll give you this little squiggly line. This is the real-time audio coming in. What we do is we then convert that audio into a picture. I'm actually a computer vision researcher. That's where I did almost all of my PhD work, was working with getting machines to look at images to do classification. So when I stepped into the audio domain, my first goal was how can I go back to pictures? I don't want to work. I don't want to work with audio. I want to work with pictures. So the very first thing that we do with Merlin is convert this 1D signal into a 2D signal. And so you have time and you have frequency. And again, what we're going to be teaching Merlin to do is find those visual patterns to decide that black-chinned sparrow is currently vocalizing. And hopefully these look familiar if you've never, or if you have played with Merlin, right? This is that same little picture that scrolls across the top when you open the app. That is that spectrogram. Merlin doesn't act, the AI system doesn't look at the exact same one that you look at. We make 2 different flavors, one for humans and one for the machine, but it is very, very similar. Okay, so we have our annotated files that the experts have given us. And what I do is I chunk that file up into small little pieces. In this case, we have 2-second intervals where we have a picture of 2 seconds of audio, and I move the boxes down onto those respective samples. So this first example has 2 species labeled, a kinglet and a red-winged blackbird. And so I show that example to Merlin without the boxes. It's just the audio that you would see in the app. And what I ask Merlin, the AI system, to do is say that ruby-crowned kinglet is vocalizing and red-winged blackbird is vocalizing, right? So that's the task. It has to look at this spectrogram and tell me that those 2 species are vocalizing. And of course, I know that those are the 2 species that are vocalizing because we had experts go through and tell us that those 2 species were vocalizing. Now, the other thing, though, is that Merlin has to say that no other species is vocalizing, right? Because the human experts didn't tell us that there's anything else vocalizing. So besides just telling us what is present in that image, it has to also tell us that nothing else is present. And we're going to do this for all of these examples, right? So now we move on to the next example. We've got the red-winged blackbird vocalizing, the yellow-rumped warbler, and the song sparrow. So those all have to be listed as Merlin is tasked with saying that those are present. And now the ruby-crowned kinglet is no longer vocalizing. It's not in that example any longer. And there's no northern cardinal. Go on to the third example. Here we have our ruby-crowned kinglet, and our song sparrow is continued from the previous time step. So it has to keep saying that song sparrow is there. Now we have a ruby-crowned kinglet, and everybody else is no longer present, right? So this is Merlin Sound ID is actually an image classification problem. We look at that image and we just say what species are present or absent in that image. Yeah, actually, I'm kicking myself. This slide is old. This was for the previous model. If you have an iPhone, we just released a brand new update to Merlin. you now have 1,380 bird species. In Android, you still have 1220. That update is coming out maybe next week. When we built this model, we had 95 days of training audio. And during the course of learning, Merlin listens to a given piece of audio multiple times, right? It's kind of the same thing that you would do if you were learning a species. You listen to it and you rewind, you listen to it again.
Uh-oh.
What did I do?
Oh, interesting.
There's.
The church is up there. Come on, keep playing. Keep playing.
Yeah.
All right. Just stand there.
So you listen to audio multiple times when you're trying to learn a vocalization. So does Merlin. And so in this particular, for this particular model, it was 39 years of cumulative listening for Merlin to learn these 1,200 bird species. For the latest model, that's been up to 50 years of cumulative listening. And with the kind of amazing power of modern computing, that 50 years of listening is done in 3 days. Which is, yeah, I mean, it's kind of like what messes with you when you like think through that. But yeah. Okay, so Merlin is now taught, but that doesn't mean it's doing well. That is like, you know, you should never trust a machine. You should always quiz it. And so that's where step 4 takes us is testing Merlin. Now, a question that I get asked all the time is how accurate is Sound ID? And it's such a funny question to me because it's kind of like asking how accurate are you at listening? And like, what does this mean? Like, I don't even know how to answer that question. So Merlin is not, it's not a classic image classification problem. We have to both detect a vocalization and try and tell you which bird species it is. So instead of talking about accuracy, we ask questions like how precise is Sound ID and what is the recall rate of Sound ID? So we'll dig into what these mean. So let's imagine we have our test set for Northern Cardinal. So we have 20 examples of audio. These are these little spectrogram 2 to 3 second little snippets. The ones on the left have Northern Cardinal as annotated by our experts, our human experts. And the ones on the right do not contain Northern Cardinal, right? We know the right answers. And we're going to make Merlin listen to all of these audio files and tell us which ones it thinks has Northern Cardinal. All right, and so maybe it goes through and it says, these are the ones that have Northern Cardinal. All right, so now we want to ask how precise was Merlin? All right, and so we're going to ask what fraction of the audio clips that Merlin said had a Northern Cardinal really have a Northern Cardinal, right? When Merlin says Northern Cardinal is there, should we, how much should we trust it? So we'll come back to Merlin's predictions, right? Those ones on the left, we know that has Northern Cardinal. So those were all right. Those get green. Now these ones that it predicted on the right, that was the hallucinated Northern Cardinal. It was not there. So that's incorrect. So we measure precision as the number of green divided by the number of green plus red. And in this case, it got 75%. So that's 75% precision. Now, if you just focus on precision, this metric can be gamed. And it can be gamed by just having your model predict one example that it's really sure that it's a Northern Cardinal, right? And most often it's right. And in this case, if you measure precision, there is no red, right? So now we have a precision of 1, we're at 100%. Now, this is not a great system because it missed all of these other Northern Cardinal vocalizations, right? So precision by itself is not enough to decide whether a machine learning system is good or bad. It's just one number. Okay, so the next question that we need to ask is what fraction of Northern Cardinal vocalizations are detected by your system? So we can come back, oops. So we'll come back to the set of examples that Merlin said had a Northern Cardinal, right? The ones on the left are right, the ones on the right are incorrect.
We're just going to focus on the ones that have a northern cardinal, right? Again, we know that because our experts told us that those audio files have a northern cardinal. So here we've got green as Merlin found those, and it did have a northern cardinal, and the orange is all the ones it missed. But a northern cardinal was present. Merlin just didn't hear it. And so we're going to measure that as recall, which is green divided by green plus orange, right? And in this case, Merlin has a recall rate of 45. Now, just like precision, this metric can be gained, right? And it can be gained by just saying everything has a northern cardinal, right? Because all we're going to work, like that's definitely going to get all the examples that did, and this metric doesn't care about these ones on the right, right? So in this case, all of those samples are green, and we don't have any orange. We didn't miss anything on the left-hand side, so we have a recall of 100%, right? So precision by itself isn't good enough. Recall by itself isn't good enough, but together, that's what we're after, right? So we look at the predictions that Merlin generates on our test set, right? It never got to look at these or listen to these audio files for training. These are just for testing. And from those predictions, we'll generate these two metrics, precision and recall. And we'll do that for every bird. So now you're seeing a scatter plot where each bird species is a blue dot, and we've just plotted its precision versus its recall. And there's 4 quadrants on this plot that I've kind of divided with these dashed lines. Those species in that upper right-hand quadrant, those are doing good. Those have high precision, in this case above 0.9, and they've got high recall above 0.7, right? So if that bird is vocalizing, you got high recall, so you're probably going to pick it up, and you got high precision, you're not going to mislead the user. Now, these species in this lower left quadrant, these are species that need to be improved. They have either, or in this case, they have both. They have low precision. They don't, sometimes Merlin will predict them and that bird wasn't actually vocalizing. It's hallucinating that bird. That's our precision. Or it is vocalizing, but Merlin's has low recall on it and it's not saying anything. It's not going to report, that species. And so the expert annotators that we're doing the boxing, they're also going to help come in and look at those birds in that lower left-hand quadrant and try to push them into a different quadrant, right? Preferably, we always want high precision. We don't want to ever mislead users, right? If we put a prediction on the app, we want that to be right. So that's your precision. The recall is what makes the app engaging, right? When you're sitting and you're holding your phone and a bird's vocalizing, you really want the app to show you what's vocalizing. And that's that recall rate. So there's always this tension between a really accurate system that's precise, but maybe very conservative, and it doesn't want to tell you predictions all the time, and a system that is just throwing answers at you because it wants to be really interactive and engaging, and it has high recall. So there's always this tension, and we're always striving to get these birds into that upper right-hand quadrant. Okay, so yeah, how do we improve one of those species, right? You kind of have these two different options. One is to iterate on the data. So we go back to our citizen scientists. We go back to the eBird community. We're like, guys, we need more audio. We need more examples of this bird. We go get more annotations on those files. And we do annotation review, right? Humans make mistakes. They're not perfect. And maybe someone misidentified some of the vocalizations in our data set, right? We need to go back through and clean those up. Option 2 is sort of R&D, right? So we focus on just the machine learning aspects. We're trying to figure out how can we squeeze more performance out of the data that we have, or how can we re-engineer the system to improve either precision or recall. We have to do both. Any good machine learning system is going to be doing both of these at the same time. Option 1 is almost a surefire way to improve performance, but it's slow, right? Because humans are involved in every step of that piece. Option 2 is more risky. There's not always guarantees that you're going to see improvements from some of this R&D, but if you do, it often helps everything, and it can be sort of this big jump in performance. On the data quality review, we do a recording mechanism on every model that we train for Merlin. So coming back to our yellow-rumped warbler example, what you're seeing here is a kind of Merlin's own assessment of the data set. So the AI's assessment of the data set. So each row here is a situation where Merlin is finding yellow-rumped warbler in a recording that the human said that the yellow-rumped warbler was not present, right? And so now a human can come back and look at this and be like, okay, let me go into this file. In this case, this was the gray catbird. This was the file that corresponds to row 1 there. The human can go into this and be like, well, let me see. Do I hear a yellow-rumped warbler in this recording? And in this case, you can visually see the yellow-rumped warbler chip notes here and here and here, right? So again, like humans make mistakes, and maybe the human was just going too fast, or they forgot to come back through and annotate this yellow-rumped warbler here. But this is how we can improve the quality of the data set and then redo our evaluations. Okay, so that's the whole system. Those were all the steps, and we literally just keep going back through these things. We go back to collecting audio, annotating the vocalizations, teaching Merlin, and testing it. I mentioned we have those projects in Merlin Vision where the annotators come in and work on species that are kind of focused on particular geographic regions of the world. Our first model came out in the summer of 21. So we took about a year to go from proof of concept to the first production model. So summer of 2020 to the summer of 2021. And we focused just on 458 species, all basically in the United States. Canada benefits obviously from most of the species, and Mexico benefits a little bit. We then had, we then had another next release the following spring in 22 that we focused on Europe and brought on another about 200 species, common species from Europe. Sound ID in the fall of 22 brought on additional species. We just, like, it's actually, you can barely even see the color change for South America. Because there's so many species in South America, right? So like, it's just going to take a long time for that part of the world to look brighter. But we started to penetrate down into the neotropics. And then we had our spring of 23 model, which took us over 1,000. And again, focused on India and the neotropics. So let me go back, and you can kind of see India lighting up a little bit more. Again, a lot of diversity there. It's going to take us a while to see some real color pop. And then the most recent model, except for this one that literally just came out this last week, was this model that took us up to 1220. And again, kind of focused on the neotropics and picking up some more common species in the US and Europe. This has been a huge success. I mean, Merlin was always a good app for birders, but Sound ID has kind of like completely opened this up to a much wider range of users, as well as even more of the birding community. So we were seeing nice growth patterns, kind of consistent growth patterns. And then when Sound ID came out, we saw this like exponential growth in the number of users. We'll probably hit 1 million users using Sound ID in one day this spring. I'm kind of hoping like May 15th-ish, we'll see like 1 million folks using this app all at the same time. But yeah, this is this has just been a fantastic project, and we've gotten great reception from the communities. And yeah, the future is really exciting. So I do most of my research around public engagement applications. I like to build stuff that I want to go use when I go outside for hiking or biking or whatever. Now that we have really good systems that work, pretty well, we can start focusing them on conservation projects, right? So for a long time, ecologists and biologists have put out what we call ARUs. These are autonomous recording units. They go strap microphones to trees and record for months at a time. And it's so laborious to go back through all of that audio and listen to everything and try and figure out which species were present, which ones were absent. We can now just listen to all this with Merlin in milliseconds, right? We can crunch through hours and hours of audio in just a fraction of a second, and get not perfect results, but results that can help push their research agendas forward and help with conservation actions for sure. Yeah, and then there's like, if you guys have never seen Birdcast from Cornell, you should be looking at it right now because we have migration happening. In the future of kind of pairing radar analysis with large scale acoustic monitoring with people, right? We're never trying to remove people from the equation. We actually want more people participating, but fusing all of that information together will give us even more detailed looks into the status and trends of our birds. Yeah, and then hopefully this came across. Merlin's a huge team effort. We've got domain experts that can do all this annotation. We have machine learning folks. We've got engineers and developers. We have people contributing audio. These are just a few of the people that have been on the project in sort of important manner. So Drew and Jay still help spearhead a lot of the stuff. Again, Taylor was this one from UMass who really helped kick off this whole project. But yeah, just a whole variety of folks that have helped make this thing a success. And again, the annotators, right? There's these folks that are just drawing all these boxes and really the ones that are responsible for teaching Merlin. And it's a huge thanks to them for all their hard work. Yeah, and thank you guys.
All right, well, let's take the questions for the people here first.
Okay.
And see what questions they have.
How does Merlin handle the mimics like the mockingbird? Versus-
Yeah, no, that's a great question. Yeah, so that's something I think we just don't handle. We'll throw up a whole bunch of.
So if you're listening to a mockingbird, it'll display all of
We'll display all of the ones that it's in, which is, it's kind of like, is it a feature or is it a bug? It's kind of cool to see all the species that it's mimicking. If you know that it's a mockingbird. I mean, yeah, we don't. It'd be nice if we handled that one better. That is tricky. So thrashers, mockingbirds, catbirds, these things are tough. Yeah.
That's actually, I think, nice that it show you the colors.
Yeah.
But do you ever see in that case, you can see it say mockingbird?
Every once, yeah. So mockingbird will be in the cycle.
That was a color.
Yeah.
Thank you.
Yeah, I was just want to, first of all, thank you, and it's neat, it's been so great to have this app. Since it was Whatbird before, right, and the picture we're gonna have it dial in, it's large or it's small, and then wonder of it, it helps me so much. You said that engagement is important, is anyone using this for like ear training, like playing around with sound and see if I can label it, and secondly, how about are the new local machine learning chips on device, is that helping with what you can do in that?
Yeah, no, great question. So the first one, I think that is something that the team is really excited about, and we haven't taken concrete steps. So that all that training data I showed you for the machine could be great training data for all of us as well, right? If you want to learn these vocalizations, we now have an amazing set of annotated files for you to learn from. We haven't sort of built that infrastructure out yet, but super cool idea. The chips, yeah, they make a huge difference. So when I made Sound ID in 2020, I was focused on iPhone 6, which sounds so old now. But we were trying to get this thing to work on really old hardware so that it would be nice for a lot of people. And yeah, the newer hardware is just even more efficient. And so you can leave this thing running. Hopefully you can leave it running for a long time without, crushing the battery and all that good stuff. But yeah, chips are big.
If you've got a clear recording that shows, and Merlin doesn't ID it.
Yep.
And you know what it is because you're looking at it and it's localizing. How do you recommend we handle that? Is that posted to eBird under that species? For example, a year or two ago, there was a chattering blue-headed vireo.
Oh,
and
yeah.
very clear. And Merlin said, I don't know. What?
Yeah, no, so that we need more training examples of that localization and getting it into eBird's the best way to contribute.
But how do you I guess alert the pros on the other end, that's something that is missing from play. Because you're getting thousands of vocalizations with somebody going out there and going, that's not there. It seems like there's no other way to point to that.
Yeah, so you could literally email, we have provide feedback that you could literally email us with and provide an eBird checklist that has the audio file. The other thing is, Merlin listens to the archive weekly. So you upload your audio file, we'll listen to it, and if you uploaded it to that blue-headed vireo, and Merlin doesn't detect it, it gets flagged. And we might not get to it immediately, but it's on our list of someone uploaded the audio file to this species, Merlin's not confident anywhere in it. Either that's a great training example and we need to pull it in, or What else?
Is there any work, there were rumors that you might start to do amphibians or other things potentially with the same thing, and I know you do naturalists also. For us, people that like lots of stuff. So.
Yep, so we are currently in the planning phase for amphibians and expanding to mammals as well. And so that will be partnered with iNaturalist and Smithsonian to do basically what we did for birds with Cornell with those kinds. And with that one, I think we'll take we're going to try and make it more of a community annotation process from the get-go, right? So Cornell, we have kind of a big enough group of experts that we can just reach out to start this. With the amphibians, I think we're going to need to bring in the naturalist community and kind of open up that whole annotation process. But yeah, so if you guys have ever played with Seek, which is another app that's also from iNaturalist, we're basically imagining what is Seek plus Sound ID. That's kind of the future.
Cool. I could use a good bee and butterfly identifier.
With photos, I'm guessing, or yeah. If you never use iNaturalist, so I didn't talk about iNaturalist is another one of my big collaborators. I've helped build all their computer vision systems, and so beyond birds, I mean that is another one of these fantastic communities where you can upload audio. They're primarily photos, and then you can have other folks come in and help make the identifications. And same thing, you contribute to training these models that can help then teach and empower a whole bunch of users all over the world. There were questions on
One final question. When is Merlin gonna reliably decide if it's a red eye or watch it go and sing once it's red eye. It's not, it's going
So right along with the mockingbirds, these species that have near identical vocalizations will often get to a point where we get feedback from the community one way or the other. So for this model, the new models will pull Philly. So we won't be predicting Philly for now because we just can't distinguish the two. Really the apps should be look at the bird. Yeah.
I wonder if I'm going to use it as long captures, like they leave it on the tree for 3 months.
Yeah.
Well, when that comes back in, I'm imagining there's little zones where it's confident about something, and then another little bubble where, wow, I can tell there's stuff happening, I have no idea what it is. So that's some humans. Does it differentiate like that?
Yeah. It's we've been talking with the scientists. So the lowest hanging fruit for the tool that they want is they give 8 hours of audio, and they want a file that just says what species are present and where was the most confident detection. So that's kind of the lowest hanging fruit is just that system. And then there's folks who want to know what is the change in behavior of the birds over the course of the morning or all the way through the day. And there they want the more detailed, temporal, we heard that vireo at this hour, as well as this hour, as well as this hour. That's the next layer, kind of cool, low hanging fruit. And then the final one is actually some notion of abundance. So can we tell you that there's 3 blue-headed vireos or something in this area from the audio?
Seems like they also want to know, wait a minute, that's a sound, we haven't heard that for, it's not even in your dictionary because it's not one you captured.
Yeah, and it's something I didn't chat about. We have this interplay between so actually on the, if you guys have iPhones and you downloaded the newest version of Merlin, we're now kind of a bit more annoying about the locations permissions. We really need to know your location because we need to know what birds are candidates for even being predicted, right? So Merlin doesn't know anything about where you are if you don't tell it. And so it knows how to predict 1,300 species. And so we kept getting feedback like, oh, you're telling me species in India. Well, it's like, well, is that really unreasonable? If you don't tell me where in the world I don't know, like birds sound quite similar in these various places. And if you just don't have any context of where you are, the results look ridiculous. And so, yeah, we kind of need to know that location information so we can get the pool of candidates. Like, okay, you're in Western Massachusetts. There's these 200 species that we really should be listening for. Yeah, so now the app is a bit more, it's a bit more forward of being like, look, if you want sound ID, you need to tell us where you are. Because we know about too many birds now. And it's too easy for us to start predicting kind of weird stuff if you don't tell us. If you don't tell us.
Maybe we try to see if we can back up. I don't know how to do that necessarily. There we go. All right, so here we have some questions. Right, Grant, maybe you can.
Oh, no, maybe, okay, so the first one was, we can't hear the playback, I'm sorry. Oh, no, okay, so all of them were, oh, maybe you can scroll.
All right, let's see.
So yeah, maybe when we shared the screen, we didn't share it.
The audio. Yeah, just audio issues. Okay, are the GPS coordinates on the cell phone recording saved?
Yeah, they're, if you look at your recordings, they should tell you where you were if you gave us location access when you started the recording. I don't know if it's easy to like directly pull out the lab one.
Good. About swamp and field sparrows.
Yep, so that's a great question. Probably what you're seeing there. So, I mean, we'd love to get those recordings, by the way, when you find a situation where field sparrow is not performing well. Back on the training data set, these systems are biased, right? The bias creeps into these machine learning systems in many different flavors. Probably what we're seeing there is swamp sparrow has more of those chip notes annotated than possibly the field sparrow. And so it's just more inclined, it's just seeing more swamp sparrow chip notes to predict that species than field sparrow. You know, and that's where we want to iteratively improve the and grow the collection of field sparrow vocalizations. But yeah, that's a great.
Yeah, and they're asking about the BirdNet and the relationship with Merlin and BirdNet. What the differences are.
Yeah, so BirdNet, so yeah, Merlin, the Lab of Ornithology has been invested in bioacoustics for decades now. And so BirdNet was actually a predecessor of Merlin. And it is, yeah, just kind of like a precursor. And we've locked up, we won a whole bunch of lessons about how those folks ran their project. And probably the big difference now, so BirdNet is still around, you can still access it. The big difference is it's not benefiting from this cycle of improvement with humans in growing the database and doing the performance review. So it's kind of more of a static tool that doesn't necessarily improve over time.
Yeah, and this last one's asking about background noise and how it can be a problem for Merlin, the ways to eliminate some of the background noise.
Yep, so I mean, if it's just windy or if it's just loud, I mean, great. So always best to try and find a quieter, more wind protected area to do the recording. You can also try to protect your phone's microphones. So they're often, by the way, the microphones are often on the bottom of your phone. And so I'll often hold my phone upside down, right? Apple doesn't allow you to rotate the screens anymore. Kind of they don't like it because your face recognition camera is upside down. But anyway, I'll often hold my app upside down so I can point my microphone at the subject that I'm really trying to identify. You can also get plug-in microphones, right? So if you really want to get into this and you really want to squeeze the best performance out of Merlin you can get a little shotgun mic. And I can send you some information about that. And that will be better than the built-in microphone. So these mics are really tuned to like speaking, like human voice and the frequency that human voice is at. And it's Apple and Google have optimized their hardware for that situation. So we're already kind of hamstrung with phones. But you know, the app can still work quite well. But yeah, you can get yourself a better microphone if you really want to squeeze as much performance out of it as you can. We actually train Merlin with background noise. So we have a whole nother, I just talked about bird training data, but we have a whole nother collection of data that has like the sound of AC units and cars driving down, dogs, yeah, motorcycles. Yeah, all this. Yeah, we explicitly try to get Merlin to ignore that stuff and not confuse it with this. Yeah, so we analyze the audio at 22 kilohertz, and the spectrograms are then generated between 0 and 10 kilohertz. So that's your human speech is kind of like in the range of 0 to 3 kilohertz, and so that 3 to 10 kilohertz is kind of above most of our speaking voices, and that's a lot of bird folks are. Morning doves, you'll see like low frequency noises, morning doves, raven, crows, grouse type stuff, are all down at the bottom of the spectrogram. Yeah, and all of the, actually, so one of the things, back to the hearing, I asked about, the quizzes. So some of the best feedback that I wasn't expecting to get from this project, and it's been super heartwarming, is folks who are starting to lose their hearing, for various reasons, and Merlin, Merlin's not restricted by, aging or other issues, and so, it can still hear just fine at 10 kilohertz, and can help you identify species that, might just be out of your hearing. Yeah.
Might be to go on the top, you can go back up. Where'd it go? I'm doing all kinds of stuff, yeah. Okay, just play back. So I guess that's it. All right. Well, thank you, everybody that's online. We're gonna stop the recording.